first talk. Let's see if I can follow it up. Yeah, this talk will focus a bit more on the philosophical question of what is a platform, and that's me asking that question: what is a platform, and kind of how does it integrate, or how does it work well with AI, or which components of a platform are now relevant in this age of AI. And I'm not joking that this is what I look like, so that's my first draft of the talk. I actually prepared a version of this talk before AI was a thing, or before AI was that big of a thing, that I did at the KCD last year. And this is kind of the new or next iteration of the talk. But first, to introduce myself, hi, my name is Damjan. I'm the CTO of Sedio, so I'm responsible for the engineering department here, kind of set, hopefully, the direction of what we do. And for me, this is kind of a topic because I'm interested in software engineering. I'm also interested in platform engineering. I'm also interested in AI engineering and just in general engineering. And I will try today to define what a platform is, or at least I say try on purpose. But why do we want to define a platform, and why am I trying to define it? So from my background, I started my career as a software developer, pretty standard, then moved into this DevOps area, where I worked on a large online transaction processing engine, one of the largest in Austria at the time. And there I had kind of my first shift from, okay, I develop software, do I need to run this software, and it needs to run somewhere at scale where we expect, I don't know, 4 million users and 200 transactions per second, and this is financial data, transactions that they have to go through, and if they don't, it costs the company a lot of money. So we moved away from, or I moved away from this mindset of, okay, you build the software, software runs, you have pretty colors on the screen, all good, and into this direction of what does an outage cost and how can we stop this? So how do we build resilient software and reliable software that works 24/7? Then I did a good job on the project. So then this project was kind of continued its life, or a part of this project was taken then out and developed further as a developer platform or application platform, as we called it at the customer. Meaning we thought to ourselves, well, this went well, wouldn't it be nice if all of our projects went like this, and we can have a platform where one of our 600 Oracle engineers can now do Java applications, and they can simply come to the platform, click a couple of buttons, and then you have a Java application. It runs, it's all great. We developed this platform. It's been running for quite a while now. It's, works rather well. And at that point, we together with the customer thought, well, the developer, the application platform went really well. We would like to have the same for data. So I think data mesh was a buzzword at the time. It was also a political topic. Can we build a data mesh? Can we call it a data mesh? What even is a data mesh? How about we align on a data platform? Because platforms worked very well for us before. Let's just do this. And we started with the work there. We developed this data platform, or are still developing, further developing the data platform. And the goal was, or the idea was, to connect data from different departments and bring it all together. And at some point, the customer also was interested in increasing their reliability throughout the company. And they also asked me to kind of work together with them to establish an SRE team. So site reliability engineering, where I had to first sell the idea to management, meaning lots of management slides, explanations why this is a good idea, why, even though it costs a lot of money, it will bring them a lot of value, and how this whole thing works together. Discussions starting from how do we want to automate our responses and do disaster recovery testing, all the way to, okay, but now who will be responsible for creating storage buckets in the cloud? So we went through it all. And this is not to say that I want to brag that I've done a lot of things. The idea more is to show that I've kind of gone through these different views of what software development is and what you need to actually develop and run software. And I have a bit of an insight from the different perspectives. So I developed software. I was thinking, yeah, this system is a bit restrictive, doesn't let me do what I want. Then I built a platform where I was like, developers do weird things, I should restrict this even more. Back to developing, where I was like, on my own platform, where I was like, what was I thinking when I did this? So I've seen things from different sides, and I came to this conclusion that it's very difficult to get kind of these different areas for different sizes, different roles to agree on a single simple and, more importantly, useful definition of a platform. So everyone kind of has this idea of what a platform is. Everyone knows what they kind of want to get out of it, but nobody really talks to each other and agrees on these topics. So it's kind of, yeah, for a platform engineer, a platform focuses on golden path, security, governance, and then this is what we do, and then developers need to use it the way that we want them to use it. For developers, it's, oh, there's a bit of a loss of flexibility, so they kind of try to look for a way in between these things, and then along comes AI busting through the door and kind of going into this direction of now everything is changing. It's changing how we work. It's changing how we deal with data, how we deal with code, how we create code. What does generating code even mean? What does code quality mean? So all of these things are kind of being changed as we speak, and we have like different experiences from customers who say, yeah, we don't need an application on top of a database now to query the data and to present it in reporting cases, but we can just put an agent on top and just get the data out and be able to kind of have this conversational database access. To customers who say, yeah, AI, absolutely not in our house, and everything in between. So it's a field that is in flux, and it has an impact on software engineering, has an impact on data engineering, and has an impact on platform engineering. So let's get the easy stuff out of the way first. You don't really know what a platform is for you until you've built it, because a platform is specific to a company. It is meant to address the needs of that company, and therefore it's kind of, the platform is what you make it, and until you make it, you don't really know what it is. It's very difficult to define up front. We had different ideas when we started, for example, with the application platform. Originally, we wanted to develop an e-commerce platform where we said, yeah, e-commerce, and then there's the web shop and people can buy stuff. So the idea came from there. And then we started building, and we were like, but then we need to be able to provision different tenants, and we need to be able to do this and that. And then at some point we were like, yeah, for this to work, we actually need to have an underlying layer. And then we started working on that. And then at some point we realized, okay, we're building an application or a developer platform. And we decided to spin it off into a separate thing. And this is how we build it. We build it up. So then it was built as a separate product within the company, so internal product, and was then provided to the retail platform in the end as an underlying base infrastructure, so that the customer could build the e-com platform on top of that, and then other products as well. Which goes to show that in the beginning, you're not really sure. Of course, you have some goals, something you want to optimize for, but you're not really sure what it will look like for you as a company, because you want to customize it, because you always need to make certain trade-offs. So you have transparency, you have compliance, you have speed or productivity, you have governance, and all of these things sometimes play against each other. So you kind of want to have both things at the same time, but usually this doesn't work. Like the most simple example is you want to move fast, but you also want stability. And by its definition, introducing changes to a system reduces the stability of the system, because if something was running and you don't change it, it's very likely that it continues running. If something was running and you make a change, no matter how good, the likelihood that the system then has less stability is by definition larger. And this is just one example. So during this platform development, effectively what you end up is you end up making choices. You have to choose between productivity and stability. You have to choose between speed and governance. You have to choose between flexibility, and so making it easy for developers to build stuff, making it easy for maintainers and platform engineers to maintain and develop the platform. These are all trade-offs that you effectively need to make. And these trade-offs will in the end define what your platform is. This is how you arrive then to what is a platform. But I would like to go through some of the main goals of platforms, which will hopefully help us kind of get a feeling, not really define a platform outright, but define a platform by its features. Just look at what platforms usually aim to achieve, and hopefully by that we come to some sort of common definition. So the first goal that I mentioned is we want to increase productivities for platforms, and this is usually the go-to thing. Like when you say I want a platform, what you mean is I want my developers to be able to ship faster, and this I can usually achieve by having something that makes it simple and easier for them to develop and ship code. There's obviously a clear kind of line there, which means you must be at least at a certain size of a company, of an engineering team, for this to actually make sense. You have 4 developers, and then out of these 4 developers, 2 develop a platform and 2 develop software on top of the platform. Obviously, this will slow you down. If you have 400 developers and then 10 develop a platform and the 390 can actually use that platform, usually this means there's a speed up. There is a very scientific curve that I have later on that will try to illustrate this, but effectively this means that when you start building the platform, usually you have a dip in productivity because you're learning. First you're dedicating resources to the platform, then you're learning, you're exploring, you're getting feedback, and this kind of then pays off as the size grows and as the platform matures. This means that you have to be careful, not just with platforms in general, but also with AI platforms. So it's kind of a topic where you're thinking, well, productivity, will it bring me, am I at the right size? Will it bring me something? And especially if you think then with AI that you usually get some productivity boost if done right, just with Gen AI, then potentially you need to think about the trade-offs here. The next goal that usually comes up when we talk about platforms is stability. So it's usually kind of up there with productivity. The idea is changes reduce stability, but there is something you can do to make it kind of better. And one thing that you can do is kind of standardize across the stack so that when something goes wrong, you don't have to think too much, oh, is this wrong because, I don't know, Java has a bug, and then, oh, but this service is not Java, it's actually the JavaScript service, and then, oh, well, we use Python actually to get this API call and so on. So by having this standardization, it makes it easier 3 o'clock in the morning to figure out or to troubleshoot what might be the cause of an issue. It also kind of standardizes the way of doing things. So you have this golden path that the platform supports, meaning for the teams, it's clear what is allowed and what is not allowed, how to build the software in a way that is hopefully reliable, how to build the software in a way that the SRE team can then understand and run. And it also standardizes the rules of the game. So you clearly know this you can do and this you cannot do. And there is a way that the company as a whole can better understand what is going on. Because by having this unified stack, there is a central place where you can look and understand what is running, what software is running, what environment is it running in, what dependencies are there, what patches have been applied, what potentially might be causing a problem, what resources I have available. All of these things are visible into this central place, which is the platform. There is also the third goal, which is compliance. So this comes especially in play when we talk about patching, for example, but also when you think about things such as GDPR, when you think about things such as AI Act or whatever. And a platform offers a relatively elegant solution to this problem by saying either I stop people from doing the wrong thing, or at least I make it so difficult that it doesn't happen by accident. So if somebody does something wrong, they did it on purpose. And it could be a valid reason. It could be they did it on purpose because this is a real use case for them. Or it could be a malicious act, but at least then you have a way to check this and you have a way to alert on this and figure out what is going on. So yeah, effectively by having this platform, you have this compliance view on top. Usually this is not the go-to thing when you say, let's develop a platform. But very soon as you start doing this, people start asking, what are you doing and why is this huge budget position open? And this is how you can usually get the higher ups by saying, yeah, sure, we spend a lot of money on a platform, but you get compliance, and then the internal governance team is happy they can check what is running. And by check what is running, there's also the next thing, which is transparency. So you have your nice UML diagrams, you have your nice architecture, but in reality, code is messy. And running systems are messy. And I don't mean messy as in somebody wrote the code in a way that is not clean code. I mean, it's a living system. It changes, the configuration changes, the environment in which it runs, changes. And all of this kind of has a compounding effect. So you start with a clean, nice thing, and then you end up with cables everywhere. And for startups, this kind of chaos mode is a feature because what you want to do as a startup is just experiment, just run in many different directions, make these small bets, see what works, give up on the stuff that doesn't work, focus or double down on the stuff that works. And you can just, move quickly, break things, and learn effectively. For enterprises, things are a bit different. So usually life revolves around budget cycles, and you have to do things slowly. There's committees, there's Steuerkreis, Lenkungskreis, everything that you have to go through. And this means that you want to know what the thing looks like, and you want to be able to kind of show this and verify this. And this is how you can also sell the platform. You can say, look, so usually when you go and say, I want to build a platform, you say this will be the tech stack. The truth is there's always changes, life is messy, you will end up with something like this. The best thing that a platform can do is tell you what is actually running and not what you want to have running there. And I think this is also a very important thing when we talk about platforms. So you have a company of, hundreds of engineers. Each of them wants to do things a bit differently. Each of them has a different, image locally that they've pulled as latest, and they don't even know what version is there. Each of them pushes things differently, and at the end of the day, you cannot always control what makes it to the platform, but you can at least say what is there. And this has a value on its own. So this was kind of my standard thinking of why platforms are valuable. I had for each of these goals also things that you can do to better utilize them. But AI entered the game. And at this point, I thought to myself, well, how does AI impact this platform development thing? So as I said, it suddenly becomes much easier to generate code. So this stall to ride or the price for entry into the industry became much lower, meaning it's much easier to get these productivity gains for experienced developers, meaning also non-experienced developers can enter this industry at much easier because you simply go to, Claude and say, hey, I want to build something, and then it will give you something resembling code and resembling a working system. And the trick is to say if it is a working system or not, and this still falls on you as a developer. The fact is that not all of the developers approach this the same way. So some embrace the chaos, some say, yeah, let's go all in, let's just spin up my 20 agent swarms, see what comes out. Some are kind of more cautious, more afraid, more thinking, well, if I let my AI agent work here, who knows what happens, who knows what comes out, and then I'm blamed for it, or it ruins my perfectly fine code base. And this effectively means that you need to balance these fears out. And the worst thing in bigger companies is usually the business department and the creative people are much faster at adopting these things. They are, what's the word, unburdened by the fear of what might happen if AI gets access to the company data. They only see the opportunity. They see, oh, well, this thing can do my job much faster, and they start installing it. So I've seen Flappy Bird clones running on 2 terabyte machines that cost 100,000 euros because one guy was like, yeah, I wanted to make a game for the marketing department, and this machine I had access to, so I just installed it. And obviously he was from business, not from IT. Why he had access to the machine is a different topic. But this now becomes much easier. So at least he had to know how to run Python on the machine in order to be able to install this. Now you just have access, and you need an AI agent that, or an AI API that you can tell, hey, I want to have my Flappy Birds clone there. And what will happen, nobody really knows. And this shadow IT develops unless you channel this energy in an effective way. And I think you can do this with an AI platform. But when we talk about AI platforms, in reality, we are talking about two different things. So the first thing is more the direction of the first talk, which is AI is the product of the platform. Effectively, what you're doing is, this is a pun from me, the aim of this AI platform is to make it easier to access LLMs or AI models or whatever. So it's about people who want to use AI, and you want to make it easy for them to use it. You want to make it secure. You want to make it compliant. The goals of this platform effectively overlap with the goals of the other platforms. So it's productivity, it's governance, it's stability, it's transparency. You can more or less follow the same ways or the same recipes for success that you would in a normal platform. And how do you get a better platform? Well, this is my super scientific graph that shifts to get the gains sooner. But effectively, you use this standardization approach. You focus on pre-approved processes, like what the first talk also indicated. You have these models that are there that you're allowed to use. You have the security around it. You have the tenants with the different rate limiting quota and so on. You have billing around it. And this standardization allows you to basically just go out there and say, hey, team, whatever company, here it is, you can use it, do your best, let's see what comes out. And you make this break-even point here happen a lot quicker. So what you do is basically try to onboard more people, try to get more feedback, try to iterate, learn, get more knowledge and get better, try to stop people from doing the wrong thing, so hopefully they don't burn through your token budget, and make the things difficult. So this is the standard approach, standard recipe. This is more or less how you would treat this on a very high level, of course. There is also another way. So vibe coding. You saw Hannah already. This is Hannah working on our web page. So effectively, you can use AI to accelerate development, whether you call it vibe coding, AI-assisted engineering, different levels of maturity. But effectively, what it means is you use AI not as a product of the platform, but just another tool in the platform. And this can get a bit tricky because when you think about it, AI is used to accelerate software development, but you have a new bottleneck now. You have the bottleneck of software review, where somebody needs to look at what software was generated by the agent or whatever and decide if this is good enough or not. And this is a very tricky problem because effectively we have, for a long time during software engineering as an industry, we have optimized for getting the speed of software development higher because we knew that this was the bottleneck and we were never constrained by the speed of review. You could not write code fast enough that somebody could not review it anymore. And this is now no longer the case. AI can write code fast enough that you cannot potentially catch up with reviews. And the question is, how do you deal with this? So a question for the round maybe, how often do you merge code without reviews? Who here has done it in the last month? Show of hands.
Every day, every hour.
So this is a topic that is very familiar to me. I have also been guilty of this, not in the last month, but I have been guilty of this. And this is very easy to kind of go into this slippery slope of I just do it once because the guy is on break or whatever on holiday, and it doesn't matter anyway. It's a small change. But the reality is that with AI now coming up, this is a more and more important question. And I wouldn't say it's wrong to do it this way or that way, but it's a decision that you need to make and that you need to take consciously. And obviously, stability may suffer because effectively, when you use AI to generate code, you can first introduce even more changes. More changes mean less stability, but you also introduce changes that you're not sure about. And maybe at some point, AI gets advanced enough that we are no longer necessary, and then there are no problems and it does the job perfectly. As it stands right now, it needs this review or it needs some support to get the job done. Compliance is a bit endangered because because compliance works by making someone responsible for something, and you cannot make a computer responsible for anything. So that's step one. But also because if you don't have an overview of the changes, you cannot guarantee, at least not easily, that the rules were met. And finally, transparency becomes significantly more difficult. This is the nature of AI, that it's not always easy to figure out why it did certain things in a certain way. Obviously, there are efforts going into this explainable AI topic. There are efforts into understanding why things are happening. There's also the argument to be made that it doesn't matter who produces the code. If the code is checked and approved by a human, then the transparency is still there because you're not directly using an answer from the AI, but actually you have an artifact that can be reviewed and checked. But at least it becomes more difficult and it becomes a topic that you need to address. And modern problems require modern solutions. So what you effectively need to do is take a more risk-based approach to this thing. So one thing that you can think about, especially when we talk about code reviews, is which code reviews do I need to make? What is critical for me? Where does quality matter? And which code reviews perhaps are not that important? So I read a paper recently where they were talking exactly about this problem, and they were saying, well, if you can set up rules and guidelines in your organization that indicate what is considered critical or high risk and what is not, you can effectively allow AI to merge its own merge requests without, so obviously through automated testing and so on, but without human review, because perhaps it's just not important enough or not worth the effort or the money to actually invest in a human review. And then you remove the bottleneck of review, which means now the thing you're actually optimizing for, so the speed to delivery to the customer, is actually much faster. Yes.
This is exactly the point I'm finding as well. So like, I'm even skipping deploying things on staging now. I'm willing to accept a certain class of bugs, which I can immediately point the AI to the AWS logs in. But if there's something critical like payments and all that stuff, yeah, I want to really test that stuff, you know. But it's just to be complete.
So this is an effective approach that you can take. The question is, how do you determine what is critical? How do you make sure that the AI understands what is critical for you and doesn't go kind of beyond its scope and responsibilities? How do you deal with this in a way that you can actually fix it and limit the blast radius? And then, yeah, if for your risk appetite, it's fine, and you say, yeah, for me, it's more important to bring the feature out there than it is to go through this human in the loop control, that's a very valid approach. This is, of course, something that AWS found out the hard way. It doesn't always work. But it's an effective way, and it's, again, brings us into this mindset of trade-offs, and you get to decide if the time invested in a review will be a good investment, will pay back for what you want to get out of it, versus if it's fine that there is an error and this error actually is acceptable. And users don't mind anyway, it doesn't matter. The argument to be made is that platform services can support with this decision, or at least this would be my argument that I put to you. And they can support by focusing on security, focusing on sandboxing, saying it's okay if I deploy something, but what I deploy then needs to be limited. It needs to have a limited blast radius. It needs to be kind of sandbox so that it cannot escape and deal damage to the critical systems. It actually has to be properly handled at runtime. Platforms can also offer testing and verification harnesses. So one of the reasons why AI has made recently such a big leap in, I would say, usability is because it's able to iterate on, so this whole agent approach means it's able to iterate on the mistakes it makes, and it's able to improve on the code. And for this to work, it needs to know if it has made a mistake and if something goes right or wrong. And the best way to do this is with testing and verification. So you effectively need to figure out first a way to say, how can I tell my agent if what it's doing is right or wrong? And then I can let it basically ask this endpoint, am I right, am I wrong? And if it's right, then continue. If it's wrong, then try to get better. There is also an argument to be made around model choice and benchmarking. So am I using the right model for this task, the optimal model? A platform can support with this, like we heard in the first talk, that you can have this model choice happen either automatically based on certain parameters, or you can allow the user to choose what model they're using. And I believe this is a very important topic, AI FinOps. So I think a lot of companies now that go in this direction of AI forget that the price that we get for AI per token right now is a heavily subsidized price. These companies are not making profit, meaning either AI gets so cheap that it's great for everyone, or prices will probably rise. And when prices rise and you're dependent on these tools for your business, then the question becomes, what happens? Can you move back? If you, I don't know, support a code base that would normally require 100 developers, and you used to do it with 3 developers and 200 agents, and now suddenly you don't have the 200 agents anymore, can you survive this as a business? And the platform can support with this by providing local models, by providing FinOps models on top of AI usage, and making sure that you kind of keep costs under control. My other argument would be that an even bigger investment in SRE and in resilience is needed, precisely for the reason that we discussed. If you accept bugs and failures in production, you need to invest in a way to fix these. And sometimes it's enough to say, yeah, my AI will access the log and it will try to fix itself. Sometimes you need to really think, can I actually roll back in production? Do I have someone that can debug the problem? Do I have someone that can, what happens when my AI generated code has processed 400 transactions and I notice that it's processing transactions wrong? Is it wrong for all the pre-processed 400 transactions? Was it wrong for just this one that triggered my alert? Do I need to roll back? Do I need compensating transactions? How do I even notify stakeholders, users, and so on? So this incident management process and this SRE approach becomes much more important and much more effective then. And finally, there's the philosophical questions, like what is even quality in the age of AI? What does this mean for software as a service products if I can just spin up stuff on my own and customize it? Also, what do I do with simple tasks that I would usually do manually, but I can now automate? What does this mean for software where it's focused on a single task and I can effectively just run it, and when I need a new feature, I can just throw it away and build it from scratch again with the new feature? What does this mean for maintainability? Is it even a topic anymore? What does this mean when I throw away software and rebuild it? What does it mean for regressions and regression tests and bugs and so on? So all of these things are kind of a bit in flux right now because the industry is changing, models are getting better, what is possible is changing, and what is kind of reasonable is also changing with it. So to go back to kind of what is a platform, the bad news is that I can only tell you about the doors that I have opened. I can only tell you what a platform is for me. And what I've seen is, for me, a platform is a piece of software that increases team productivity, does it through standardization, offers some sort of level of compliance and stability, but does this at the expense of flexibility. So when you go on a platform, you clearly give up some of the freedom for the other benefits that you have here. And the platform lives by the 80-20 rule, meaning a platform covers 80% of the use cases, and then it's fine, then it's worth it for the company. 20% of the use cases need to go outside of the platform because customizing for them or making the platform configurable or extensible enough would cost another 80% of the budget. And this means the good news is you all get to decide what a platform is. You can prioritize what is important for your company. You can build it. You can measure if it's effective or not. You can ask for feedback. And the key, you can improve and you can make it better. Thank you very much.